Scientists just calculated exactly how many minutes the ancient Egyptians had to place each block of the Great Pyramid to finish it on time. And the number is so small that for over 100 years, nobody could explain how it was physically possible. Now a new study says it finally has the answer, and it's hiding in plain sight inside the pyramid itself. For most of the last 2 centuries, if you asked an Egyptologist how the Great Pyramid of Giza was built, you'd get roughly the same answer. Thousands of laborers, external ramps, brute human force, repeated for 2 decades until 3 million blocks were stacked into the largest stone structure ever built by hand. That's the version in your textbook. It's the version in nearly every documentary made since the 1960s. And for just as long, that version has had a problem nobody could fully solve. The math doesn't add up, not slightly off. Or it genuinely doesn't work. The Great Pyramid contains an estimated 3 million blocks, averaging around 2.5 tons apiece, with the largest ceiling blocks inside the king's chamber weighing close to 60 tons. Ancient and modern estimates place the construction timeline at roughly 20 years. Divide it out, and the builders needed to quarry, transport, and precisely set 1 block every few minutes around the clock for 2 decades straight. That isn't a construction pace. That's an assembly line, operating 4,500 years before the concept of an assembly line existed anywhere else on Earth. The traditional explanation has always centered on ramps, long sloped structures made of packed rubble and mud brick, built up against the sides of the pyramid so crews could drag sleds loaded with stone to the working level. The Greek historian Herodotus, writing around 450 BC, described the workforce as slaves conscripted by the tens of thousands. Modern excavations near Giza have corrected that part of the story. Worker villages discovered south of the plateau in the 1990s show organized labor camps, complete with large-scale bakeries capable of feeding thousands of people daily, breweries, food storage facilities tracking rations by administrative seal, and skeletal evidence of medical treatment for broken bones that had been set and allowed to heal. Signs of a valued, semi-permanent workforce rather than an expendable one. Burial sites near the pyramids reserved for workers rather than royalty were still treated with a level of care that would have been unusual for enslaved laborers in most ancient societies. That correction matters historically, but it never solved the mechanical half of the puzzle. Knowing the builders were respected doesn't explain how they physically moved 60-ton stones to a height of over 400 feet, because the ramp theory carries a geometry problem that gets worse the higher the structure rises. To haul a 60-ton block up a slope gentle enough for a team to drag it on a wooden sled, the ramp has to be long. The gentler the incline, the more material and distance it demands. Multiple structural analyses conducted since the 1970s have shown that a single straight external ramp shallow enough to reach the pyramid's upper third would require more raw material than the pyramid itself contains. Researchers have proposed alternatives, ramps that spiral around the exterior face, ramps built inside the structure and later removed, combinations of both. Each version solves one issue and creates another. A spiraling ramp would obscure the very corners the builders needed exposed to check the structure's alignment as it rose. An internal ramp, despite decades of muon scanning, radar surveys, and thermal imaging across the pyramid, has never been definitively located. Nobody has found it, not a trace of the volume of construction material required anywhere on the Giza plateau. French architect Jean-Pierre Houdin proposed one of the more influential internal ramp models in the early 2000s, suggesting a spiral tunnel built into the body of the pyramid and later disguised within the finished structure. The idea gained real traction because it solved the corner visibility problem better than earlier spiral designs, and a French construction company partnered with Houdin to run engineering simulations, testing its feasibility. But even that model depends on internal chambers and tunnel sections that decades of scanning have never conclusively confirmed. Mark Lehner, an Egyptologist who has spent much of his career excavating the worker settlements south of the plateau, has generally favored variations on the external ramp model combined with tightly organized, rotating labor shifts. But even Lehner has acknowledged that no ramp theory fully accounts for how the pyramid's upper third, where the steepest inclines and heaviest lifting challenges exist, could realistically have been finished within the accepted 20-year window. This is the environment Schuring's paper stepped into. Not a settled field waiting to be disrupted for attention, but a genuinely unresolved engineering question that specialists have been debating in good faith for half a century. That gap in the evidence is what makes a study published in October 2025 worth taking seriously. The paper comes from Simon Andreas Schuring, a scientist at Weill Cornell Medicine in New York, who studies the pyramid as a personal research interest alongside his clinical work. It was published in NPJ Heritage Science, a peer-reviewed journal under the Nature portfolio that focuses specifically on the scientific study of cultural heritage sites. Schuring's argument is not that the Egyptians had help from outside technology or lost civilizations. His argument is that the answer has been sitting inside the pyramid the entire time, misidentified for 2 centuries as something else. Here's what he noticed. The Grand Gallery and the Ascending Passage, 2 of the pyramid's most famous interior spaces, form a single continuous incline. They share the exact same slope, close to 26.5 degrees, and that slope matches the separate descending passage on the other side of the structure as well. 3 passages, 1 shared angle, cut with a level of consistency that is difficult to attribute to coincidence in a monument where every measurement appears to have been deliberate. Schuring's proposal is that this shared slope wasn't decorative or symbolic. It was functional. The Ascending Passage and Grand Gallery, he argues, functioned as a sliding ramp for counterweights, not for blocks being pulled up, but for heavy sleds loaded with stone or sand that were released to slide downward under gravity. As a counterweight descended, it generated pulling force through a rope system, and that force was transmitted through the antechamber, a small granite-lined chamber just before the king's chamber that has been described for 200 years as a security feature, a set of slabs meant to block tomb robbers. Schuring reinterprets the antechamber's unusual grooves and slots not as a blocking mechanism, but as a pulley station, a place where ropes were looped around wooden beams to redirect and multiply force, lifting blocks upward through a separate vertical shaft on the chamber's far side. The mechanical logic is straightforward physics, the same principle behind any counterweight elevator or crane still in use today. A descending weight on one side of a pulley system does work lifting a load on the other side. Loop the rope around additional beams, you trade speed for lifting power, allowing the same basic setup to raise even the heaviest blocks at the cost of pulling more rope through the system. Schuring calculates that a slope of roughly 26.5 degrees is close to the mathematical optimum for this kind of system, generating enough gravitational pulling force from a descending sled while still keeping the ramp length manageable within the pyramid's existing internal footprint. Run the numbers, and the setup produces a rough force amplification in the range of 2 to 1, meaning a counterweight of a given mass could lift a block roughly twice as heavy through the pulley arrangement. That's not an arbitrary number picked to make the theory work. It's close to what you'd expect from a deliberately engineered system, rather than a coincidental byproduct of tunnels built for religious or symbolic reasons. Schuring calculates that a system like this could plausibly place a block eve RI1 to 3 minutes, which is the first proposed mechanism that actually lines up with the 20-year construction timeline instead of falling drastically short of it. One detail that gives the model added weight is how it treats the pyramid's growth over time. Rather than picturing construction as a simple layer-by-layer stacking process from a flat base upward, Schuring's model suggests the interior architecture, the passages, chambers, and the machine housed within them, was largely completed early, and then the exterior mass of the pyramid was built up and outward around that functioning core in phases. Under this reading, the Grand Gallery and antechamber weren't afterthoughts added for ceremonial purposes once the heavy lifting was done. They were the first priority, built early precisely because the entire rest of the structure depended on them functioning correctly for the following 2 decades. What makes the paper more than pure speculation is the physical evidence Schuring points to inside the structure. The floor of the Ascending Passage is unusually hard and highly polished, a wear pattern consistent with heavy loads repeatedly sliding across it rather than foot traffic. The Grand Gallery is an architecturally strange space, even by the standards of the rest of the pyramid. A corbelled corridor roughly 150 feet long and 28 feet high, far taller than any passage would need to be for people simply walking through it, with slots cut into its side ramps at regular intervals that Egyptologists have historically struggled to explain with any confidence. Under the ramp theory, those slots are usually described in vague terms as holding sockets for some unspecified wooden apparatus. Under Schuring's model, they become something far more specific, mounting points for a repeated, standardized rigging system, reused thousands of times over the course of construction. The Grand Gallery's floor and side walls also show scrape marks running in a direction that makes sense for sleds under load, but doesn't fit typical explanations, involving ceremonial use or simple foot passage. And the antechamber, which has puzzled researchers for generations because its granite slab grooves extend nearly a meter higher than would be necessary for slabs to simply drop and block a passage, fits far more naturally as housing for a working mechanical system than as an anti-theft device that was only ever used once, on the day the tomb was sealed. Schuring is careful, in his own paper, to state what the model does and doesn't explain. It's a proposal for how blocks were lifted vertically inside the structure using rope, wood, and gravity as the entire power source, with no need for lost technology or advanced machinery, just very good applied engineering by people who understood force multiplication centuries before anyone wrote down the formal physics of it. What the paper does not claim to explain is everything else that makes the Great Pyramid remarkable. The structure is aligned to true geographics, north within a fraction of a degree, a feat modern surveyors still find difficult to fully explain using only the tools available in 2600 BC. The exterior casing stones, largely stripped away over the centuries for later construction projects but still visible at the base, were cut and fitted with joints so tight that in places a piece of paper cannot slide between them. The mortar used throughout the structure has been chemically analyzed repeatedly, and modern chemists still can't fully replicate its exact composition or explain how it was applied so evenly at scale. And the base of the pyramid is level to within about 15 millimeters across a footprint of more than 13 acres, an accuracy that rivals what modern laser leveling equipment can achieve. Scheuring's paper doesn't touch any of that. It's specifically a proposal about vertical lifting mechanics, not a unified theory of pyramid construction. And it's important to be precise about where it currently sits in the scientific process. It has passed peer review and been published in a respected Nature-affiliated journal, which means it met the bar for methodological soundness and internal consistency required to be taken seriously by the field. It has not yet been independently replicated, physically tested at scale, or confirmed through direct excavation of the proposed mechanism's remaining components. Some Egyptologists have publicly raised questions about specific interpretive leaps in the paper, particularly around how cleanly the wear patterns can be dated to the original construction period, rather than later reuse of the passages. In scientific terms, this is a serious, plausible, evidence-supported hypothesis. It is not yet a settled fact, and Scheuring himself frames it that way, rather than as a final answer. So that's the real, documented, peer-reviewed science, which brings us to the second half of the story, and to the question in the title of this video, because over the past year, a very different and far more dramatic claim has been circulating online, one that takes this pyramid story somewhere the actual research never goes. In March 2025, a team led by Corrado Malanga of the University of Pisa and Filippo Biondi of the University of Strathclyde held a press conference in Italy announcing what they described as a groundbreaking discovery beneath the Khafra Pyramid, the second largest structure on the Giza Plateau. Using a technique they call SAR Doppler tomography, built on their earlier 2022 published work using synthetic aperture radar, the team claimed to have detected 8 massive cylindrical shafts descending more than 2,000 feet below the surface, surrounded by spiral pathways, connecting to large cube-shaped chambers and linking to similar structures beneath the other Giza pyramids. Some supporters of the claim went further, suggesting these structures resembled the reinforced support columns of a modern skyscraper, and speculating online that Giza wasn't a burial complex at all, but the remnant of something built on an entirely different scale, some kind of ancient megastructure disguised for thousands of years as a group of tombs. It's a genuinely compelling idea, and it spread fast for exactly that reason. The 2025 announcement wasn't the team's first appearance in this space either. Back in 2022, Biondi and Malanga had already published a peer-reviewed paper in the journal Remote Sensing, describing SAR based findings of modest internal features within the Great Pyramid itself, work that drew far less controversy because the claims were comparatively restrained and went through standard academic publication. The 2025 Khafra announcement was different in both scale and format. Rather than a peer-reviewed paper, the 8-shaft, 2,000-foot claim was unveiled at a live-streamed press conference in Italy to an audience of roughly 1,000 people, accompanied by artist renderings and AI-generated visualizations of what the underground network might look like. That's a meaningfully different way to introduce a scientific claim than submitting it for review by other geophysicists first, and it's part of why the response from the wider research community was so swift and so skeptical. But it's important to separate the excitement of that idea from what has actually been established, because the scientific response to this specific claim has been almost uniformly critical, and for reasons that are worth understanding rather than dismissing outright. The core technical objection comes down to physics. Synthetic aperture radar, the underlying technology, is well established and genuinely useful for archaeology, but it works by bouncing radar signals off surfaces and measuring the return. It's effective for surveying terrain, detecting subsurface features in sand or soil, and mapping structures close to the surface. Radar signals do not travel meaningfully through solid limestone bedrock to a depth of 2,000 feet. Geophysicists who reviewed the Khafra claims, including specialists uninvolved in the original controversy, have pointed out that this depth and medium combination falls well outside what any known radar-based imaging method can actually achieve. That's not a matter of interpretation. It's a basic limitation of how the technology functions. The response from Egyptian antiquities officials was direct and public. Zahi Hawass, Egypt's former Minister of Antiquities and one of the most prominent Egyptologists in the world, stated flatly that no radar equipment had been used to detect any structures beneath the Khafra pyramid with the level of detail claimed, and dismissed the findings as baseless. Other researchers, including the director of the Antiquities Museum at Egypt's Bibliotheca Alexandrina, describe the claims as an exaggeration that misrepresents what limited data actually exists. Independent fact-checking organizations that reviewed the underlying materials found no peer-reviewed publication supporting the 2025 press conference claims at the scale being reported, and traced much of the amplification back to conspiracy-oriented media outlets rather than archaeological or geophysical journals. None of this means every person drawn to the story is being foolish, and it doesn't mean SAR. Technology has no legitimate use in this field. Biondi's underlying radar work has appeared in peer-reviewed remote sensing journals before, which is part of why the 2025 claims got as much traction as they did. Real credentials attached to a claim can create a reasonable-sounding wrapper around conclusions the data doesn't actually support. That combination, a legitimate technique stretched into an unsupported claim, presented through a press conference rather than a peer-reviewed paper, is a pattern worth recognizing whenever a discovery this dramatic surfaces outside the normal channels of scientific publication. The 2022 predecessor study did appear in a peer-reviewed journal and reported comparatively modest internal features. The 2025 announcement, with its far larger and more sensational claims, has not gone through that same process. And as of now, no independent research team has been able to verify the specific structures described. So, are the Giza pyramids secretly ancient skyscrapers built by some unknown advanced civilization, hiding 2,000-foot support columns underneath a facade of tombs? Based on everything that's actually been verified, no. That version of the story doesn't hold up to the physics of the technology being used to support it. And it hasn't survived scrutiny from the geophysicists and archaeologists whose job it is to test claims like this. But here's the thing worth sitting with. You don't actually need that version of the story for the Great Pyramid to be one of the most impressive engineering achievements in human history. Strip away the speculation about hidden megastructures and secret power stations, and what's left is a group of Bronze Age engineers who figured out, with wood, rope, and stone, how to convert descending weight into lifting force at a scale and precision that took modern science until 2025 to properly reverse engineer. They didn't need alien technology or a lost civilization. They needed and understands of gravity, leverage, and friction good enough to move 60-ton blocks using a system whose basic principle is still taught in first-year physics classes today. If Schöring's model holds up to further testing, it means the people who built the Great Pyramid weren't just organizing enormous labor forces, they were solving mechanical engineering problems that wouldn't be formally described in Western science for another 2,000 years. That's the part of this story that tends to get buried under the more sensational version. The real discovery here isn't extraterrestrial contact or a hidden underground civilization. It's that we've been looking directly at a functioning machine for 2 centuries and calling it a tomb decoration. The Grand Gallery wasn't just an impressive architectural flourish. Under this new model, it was the engine room. The antechamber wasn't just a security checkpoint for grave robbers. It may have been the gearbox that made the entire vertical construction of the pyramid physically possible within a 20-year window. And the wear patterns in the stone floor, the scrape marks along the walls, features that have been photographed and documented for well over 100 years, may have been sitting there the entire time as physical evidence of exactly how this building was made, waiting for someone to ask the right question about what could have produced them. What still remains genuinely unexplained is arguably even more interesting than any single mechanism for lifting stone. The true north alignment accurate to a fraction of a degree. The mortar formula nobody has fully replicated. The casing stones fitted with a precision that modern stonework rarely matches even with power tools and laser measurement. Those details haven't been explained by the counterweight model, they haven't been explained by ramp theories, and they remain open questions for future research. Exactly the kind of open questions that keep serious archaeologists and engineers studying this site more than 4,500 years after it was completed. It's also worth remembering what actually sits on the Giza plateau, stripped of any speculation at all. 3 major pyramids built across roughly 3 generations of the same royal family during Egypt's 4th dynasty. The Great Sphinx, carved from a single limestone outcrop, its exact construction date still debated among specialists who broadly place it in the same era as the pyramids behind it. A sprawling complex of temples, causeways, and worker villages, actively excavated for more than a century, that has produced tools, ramps of modest scale for smaller projects, quarry marks, and the skeletal remains of the builders themselves. None of that record, built from physical excavation rather than a single radar reading, has ever pointed toward hidden megastructures beneath the sand. What it has consistently pointed toward is a highly organized, technically sophisticated Bronze Age state capable of mobilizing tens of thousands of workers, supplying them for years at a time, and solving engineering problems most modern people assume were simply impossible without machinery. That's really the honest state of where this research stands right now. One serious, peer-reviewed, physically grounded proposal that finally offers a construction method matching the pyramid's known timeline, still awaiting further verification. And one far more sensational claim about hidden megastructures that captured public imagination, but has not withstood scientific scrutiny. Both stories are floating around the internet right now, often presented with equal confidence, and the difference between them matters. It's the difference between here is peer-reviewed evidence that changes how we understand an established structure, and here's a claim from a press conference that the people most qualified to evaluate it have publicly rejected. It's worth asking honestly why the second kind of story tends to travel faster than the first. A peer-reviewed paper about rope, wood, and gravity is genuinely fascinating if you sit with it, but it's a slower, more careful kind of fascinating. It asks you to follow a chain of physical evidence, a floor's wear pattern, a slope angle, a chamber's groove depth, to a conclusion. A claim about a hidden ancient city 2,000 feet beneath a pyramid, resembling the skeleton of a skyscraper, arrives fully formed and immediately dramatic. It doesn't require you to follow the reasoning, only to feel the scale of it. That difference in how each story is built is a big part of why one spread through mainstream science journalism and the other spread through press conferences, social media threads, and channels built around unresolved mysteries. Neither pace of spreading tells you which one is true. Only the underlying evidence does that. And right now, that evidence points clearly in one direction. The Great Pyramid doesn't need the second story to be extraordinary. It was already extraordinary before anyone suggested it was secretly a skyscraper. A structure built without modern tools, aligned with an accuracy modern engineers still study, assembled at a pace that seemed physically impossible until a mechanism finally explaining it was published just months ago. Sometimes the real answer, the one that survives peer review and doesn't need a hidden civilization to make sense, turns out to be the more remarkable one anyway. If this kind of deep dive into how ancient engineering actually holds up under modern scientific scrutiny is something you want more of, subscribe to the channel so you don't miss the next one, and drop a comment letting me know which theory you find more convincing, or if there's another ancient mystery you want properly fact-checked next. Thanks for watching all the way through, and I'll see you in the next one.